right. Good morning, good afternoon, good evening, wherever you're tuning in from. Thanks for joining us for another episode of the Machine Learning Community Stand-Up. I see that we already have folks joining us from the Philippines, so hello, welcome. And with me today is my co-host, Jake, and our guest, Diego.
Hi.
Unfortunately, Bree could not join us today, but she's here in spirits, and hopefully she'll be back on our next stream. So yeah. But before we get started, Diego, would you like to tell us a little bit about yourself?
Yeah, I'm Diego. I'm from Ecuador. I live in Quito, and I'm very excited to be here. I'm going to talk about data scientist versus data engineer. It's a very interesting topic because it helps me a lot when I have to pitch a machine learning project using ML.net. So I hope it can help you as well.
Awesome. Yeah, that's really great to hear, and I'm really looking forward to your presentation. You're going to be talking to us about data scientist and data engineer, and which one should you choose? Apparently, these are different roles, so I'm really looking forward to that, especially for folks who may be getting started in their machine learning journey and starting their career in this space. So I'm really excited. Um, hey, Flippy, welcome. So before that, so before we get started with your presentation, let's go ahead and share some community links. So let me pull up my screen here for a second. So today is going to be a short one, but there's a ton of recordings here available that you can take a look. If you're not aware, this past weekend on Friday and Saturday, we had the Machine Learning Virtual ML.net Community Conference. It was a 2-day event. We had a lot of great community speakers talk about different topics and case studies. Some of them were related to, for example, creating race strategies for Formula One. We had other presentations that involved drones and performing anomaly detection. We had some scenarios that showed how you can do deep learning with ML.net, as well as a few intro sessions for folks who are either getting started with ML.net that would like to know what the best way of getting started is. Again, it was a 2-day conference, so you can find all the recordings here. There's a playlist that was created, and it's in the Virtual ML.net Community Conference channel. So if you go there and you look for the Virtual MLNet Conference 2021 playlist, you can find both day 1 and day 2, and the full recordings are there. And as you'll see, there's also some timestamps as well, so that you can take a look at the individual presentations and jump to the ones that really jump at you. We had another show here. In this case, Bree and I went on the on.net show with Cecil Phillips, where we talked a little bit about ML.net, how you can get started, and we showed off a few things. One of which is minimal APIs, which is this sort of relatively new app model that you can sort of put together as part of .NET 6 for deploying your machine learning models with minimal configuration and as little code as possible, using some of the latest C# features like top level statements and some other language features. Let's see here. Last but not least, a shameless plug there. Let me pause that real quick. Yesterday, I was on a stream on Twitch with Layla Porter, who is part of the .NET Foundation. And we basically did a whole walkthrough of how you can get started. Let me pause this. For whatever reason, it's not pausing. But we did a whole walkthrough of how you can use Model Builder to get started building machine learning models. Unfortunately, we started training an image classification model. And as you folks might expect, right, that typically requires more compute. And especially with streaming, I think we barely made it to 50% training. Not quite sure how far we made it, but unfortunately we couldn't finish. But at least we got one model trained to predict Netflix ratings based on various inputs like the title and the genres and different things like that. So make sure to give us a look to see how you can get started with Model Builder, and also just check out Layla's stream. She does a lot of really cool stuff across .NET and a lot of .NET technologies, and also some non.NET technologies. So make sure to check her stream out on Twitch and yeah, check it out. So with that, let me go ahead and switch the screens here. And Diego is going to be talking to us about, again, a data scientist and a data engineer. What are they, and which one should you choose? So with that, Diego, take it away. The floor is yours.
Okay, thank you, Luis. So let me introduce myself very quickly. My name is Diego. I work as a solution architect in an insurance company here in Ecuador. I also work as a machine learning consultant. And you can find me in any social media with this key, DF Mera, DF Mera, any social media, even TikTok, whatever, you can find me there. So let's begin talking about why it is important to know the difference between a data scientist and data engineer. So let me tell you a short story. Back in the old normal, in 2018, me and my team at work, we had this idea. We said, hey, let's build a machine learning model to predict if a customer is going to renew their vehicle insurance. Great idea, right? So we studied machine learning, but we studied a course in a very traditional way. We learned a lot about theory and a lot about commands in R. It was a great course, but we didn't learn how to build a project. We never knew how to take all that theory and to build something with that. So what did we have to do? Basically, we have to call the teacher or teacher, and we tell him our idea, and so he can help us to build this project. And we collect a lot of data using SQL because we didn't know anything about Python back then. But SQL is a great language to collect and explore data. And we ended up building the code for the project. But now we had another problem. How do we sell this? How do we sell this project? We had to sell the project to the CEO of the company because we needed them to give us the resources to build the project on a large scale. But how could you sell this if we all had was this bunch of scripts and graphics in notebooks and some inferences in Excel? But to sell something, you need something more visible and more useful, right? So we basically failed trying to sell and implement this project because we didn't know how to make it visible and useful. So I had this question: how can I use a machine learning model in a real application? There was this talk in the MLnet conference. I think it was the last one. The topic was something like how can you take the project into the product? Yeah. So it's basically the same problem. You have to in some point you have to use a machine learning model in a real application, right? So still in the old normal, in 2019, I saw ML.NET for the first time. I think it was in a .NET Conf or in a MS Build or in one of those conferences. And I saw this demo and I love it. I love it. I said, hey, this is what I've been looking for. This is how I can take a machine learning project into a production, into an application, and this framework was great. I love it immediately. So I learned about ML.NET, and in 2020 we were in the new normal. I started to work as a machine learning consultant. And I started to pitching machine learning projects. But now I had another problem. I had a new problem. People used to ask me this question: hey, don't you have to do this with Python? Don't you have to use Python for machine learning? I'm pretty sure you got that question a lot also, right? So to solve that problem, I basically have to know my audience, because in order for them to understand the difference between the tools, between the machine learning tools, they first had to understand the difference between a data scientist and a data engineer. So this is how I pitch a machine learning project when I have to use ML.net. This is how I pitch it now. I have this approach. First, I start talking about the knowledge areas, the big knowledge areas, and the skills you need in a machine learning project. I don't go straight right to the talking about ML.net and the tools. I start with this little talk. So in a machine learning project, you need these skills. You have to know about business, all about business domain and how to approach a problem. You have to know about development, all about development tools, programming languages, databases, web services, security, all of that. And of course, you have to know about data analytics, mathematical, statistical models, learning algorithms, data exploration, all that. Now, the thing is, a data scientist is an expert in data analytics, right? And they have to be an expert in business as well. But they are not expert in development. The data engineer is the expert in development, and of course they have to know about business as well. So in a machine learning project, you might want to have both skills, both profiles, a data engineer and a data scientist. But what are the responsibilities each one has? So a data engineer, he has to develop and construct and test and maintain architectures. ML.net has a great advantage here because all the IT areas I've known, they have the same problem. They don't get along. You have infrastructure area, development area, architecture area, and they don't get along, right? I'm pretty sure you have that problem as well. Development says, "Hey, my code is great. Your hardware is not good." Architecture says, "No, I can't approve that architecture. That doesn't meet our standards." So ML.net is great for that, because if you already have an architecture in .NET, you don't have to worry about making big changes. You can use ML.net and you can start developing great things using machine learning. A data scientist a data engineer, also has to develop data processes, basically how to collect information from different sources. And they have to integrate systems. They have to integrate systems together with REST APIs or microservices. And they have to recommend ways to improve data quality. Those are basically the responsibilities of a data engineer. And a data scientist, they have to answer industry and business questions using data. They have to prepare the data for use in a predictive model and explore data to find patterns. This is where Python comes handy, for example, for a data scientist. Python is a great tool to explore data. And they have to find out ways to automate the work using data and predictive analytics. And this is the most important for me. This is the most important responsibility of a data scientist. they have to tell stories using data. And it's important because it is something you cannot learn in a machine learning course or with tutorials, because it depends on your data and your knowledge of the business. But it's very important. A data that doesn't tell a story is worth nothing. Nothing. It's like Tyrion Lannister said, what unites people? A good story. Remember that you have to know how to tell stories using data. Now, if you think about the process of a machine learning project, you have these steps, right? Data acquisition and exploration. A data scientist profile is great for that. You have to train a model and you have to test the model. You can do this either with a data scientist or a data engineer. It depends on what tools do you want to use. And finally, you have to consume a model. This is a very, very, very important part of a machine learning project. And MLnet takes this step very, very seriously. And why this is important? Because with this step, this is the part where you deliver value to your customer, to your client. It's like the problem we had that I told you. We didn't know how to sell a project because we basically train a model and test a model, but we didn't take the next step, and we didn't consume a model in an application. So it was very hard to sell that project because it didn't deliver value. To sum it up with an analogy, I love Formula One, so I like this analogy. Let's think in the Red Bull team. This is Adrian Newey, and this is Max Verstappen. Adrian Newey is the brain behind the car. He knows everything about aerodynamics, downforce, design. He's the brain behind the car. So he is like the data scientist for the team. But the driver, Max Verstappen, he is like the data engineer because he is responsible to take the car to the finish line. So he is responsible to deliver value to the team, the sponsors, and all the stakeholders. So that's my analogy between data scientist and data engineer. What do you think, guys? Do you agree with me? Do you think this is correct for you? Luis, Jake? Luis, Jake, I don't know if you can hear me, or is it me? I can't hear you.
I had to mute
Oh,
myself.
unmute. Oh, that's a new normal talking.
Yeah. So some folks, I mean, I certainly agree. There's certainly some folks in the chat here. Ichan is mentioning that it's a nice analogy, and agreed. Lots of agreements here. So yeah, very very well put. There.
Okay, so let's go. So now it's easier, right? Now that we understand the responsibilities, it is easier to understand the tools that each one may want to use. If you are a data engineer, you may want to use, of course, ML.net. I love ML.net. You can also use tools like Azure Machine Learning. That's another great tool. But you can use databases, SQL Server, SQL language. You may want to use Java or NoSQL databases like Mongo. But if you are a data scientist, you have to know R, you have to know pandas, you have to know TensorFlow, all those things. And Python. Python, I think, is a great language for data scientists and for data engineers, because if you want to build a microservices using Python, it's a great idea. And you can use Python to explore data as a data engineer. So Now it's easy to understand the tools, right? And to answer the questions like, hey, don't you have to use Python for machine learning? Well, not exactly. You don't have to use Python. You can use Python, but you can also use these other great tools. Now let's think a little bit about the projects. What are the ideal projects for each role, for each profile? A data engineer basically can perform supervised learning because in a supervised learning you already have a label, right, to train a model. So a data scientist can build an end-to-end classification model, for example, an end-to-end from the data acquisition to the model consumption. And machine learning.net is great for that because you have this approach. Actually, when I studied machine learning, they didn't teach this approach like classification model, regression model, binary classification. They teach it us with algorithms and a lot of theory. So that's why it was very hard for me to take that theory into practice, because we had these ideas about machine learning models, but we didn't know which algorithms we had to use. But with this approach, it's very simple to understand that. Of course, regression models is another supervised learning, and it's great when you have to predict numerical values. But when you have unsupervised learning, like clustering, that's a little bit harder. That's something a data scientist can perform, because you have to explore a lot about data, and you have to know the distribution of the data and a lot of things that they are a little bit more complex. So for unsupervised learning, you may want to have a data scientist profile. Also, when you have specific complex algorithms like neural networks, deep learning, that's also something more complex that you may want to have a data scientist profile. And data transformation. Sometimes when you need to improve the metrics of the model and the precision of the model, you have to perform data transformations, and you have to understand the data and the distribution of the data. So a data scientist may be a great profile for that. And that's basically it. That's why I love ML.net, because as you can see, ML.net is great to take a machine learning project and transform it into a product and deliver value to a customer, to your clients. And of course, it's easier to sell a project if you have something visible and something useful that you can say, hey, look, this is the project, this is the project working, this is the model working, these are the inferences working online in an application. So that's great, and that's why I love ML.net. That's it. That's why I wanted to share with you.
Awesome. I think we have a few questions here. Jake, did you see any that stood out to you?
Let me take a look. Somebody asked, when using MLnet, do you have to use Azure? Or is there another way to train data and save it somewhere? So yeah, I think, I guess I'm not sure if you've watched our community stand-ups before or not, or joined us, but I recommend checking out our tooling, so ML.net Model Builder, and our CLI. You can train locally there, so you don't have to use Azure. But we also recommend using Azure, especially when training large data sets. And as we go forward evolving our tooling, we're going to be adding a lot more functionality to help you do that, to train in Azure, to iterate on your data in Azure and automatically train your model in Azure. So we're going to deliver a lot of power and value from Azure, but you definitely don't need it. Our tooling is sort of a local first approach.
I've actually trained big dataset models using ML.NET in my local computer, and sometimes it's even faster, because if you want to have a big computer in Azure ML, you have to pay for that, right? So in my personal subscription, I have this code that I can't use big machines. So yeah, sometimes it's even easier to use your local machine.
Totally.
I see we have a question here from Alibaba PK, which they're mentioning. I'm a data scientist, and I know all these concepts, but I don't know how to implement in code. And by that, I believe that they're referring to things like data reduction, data cleaning, and etc. Do you have any tips for that, Diego, for getting started and going from that sort of data scientist to getting a little bit more comfortable and used to working with the code?
Well, yeah, I always hear this question also, like when you perform, when you train a model using notebooks and you write code using notebooks to clean data and all the things, they used to ask me, hey, how do I take this code into production? So my answer to that is, like, if you are writing a code in notebooks that you are going to need that code into production later, my answer is, hey, you're probably using the wrong tool, because notebooks is great for data exploration, but is not great for production environments. So my recommendation is to learn another tools that can help you to build things, that can help you to build applications like ML.NET, and learn how to know how to use the right tools for you. If you are a data scientist, that doesn't mean you cannot learn ML.NET or another language that you can build something into an application. If I answered your question, let me know, or if you have another question.
Yeah, let us know, Alibaba. I noticed that I posted a follow-up there, the point where we put our train model in our running web app. So
well, again, it depends on the tool you use. If you build a model with Python, you're probably going to have to use Python to consume that model. And I assure machine learning is great for that, because you can publish your model even without using without code, without have to write code. Azure Machine Learning gives you an endpoint to consume that model. So that's a great tool. If you write a model in Python, Azure Machine Learning is a great tool. But you can also train your model in Python. And when you already know what you need and how to solve your problem, and you already have a .NET architecture in your team with your development team, you can use ML.NET, or you can ask the development team to take that model in Python and to write it in ML.NET.
I have a question too. In the kind of going back to your slides a little bit, in data scientist versus data engineer, how do you view like the flow? So like, what tools are each of them using, and how do they sort of hand it off if they're working together?
You are talking about, like, this slide?
Yeah, pretty much. Kind of this slide combined with the other slide where you're talking about the tools that each. Yeah, that's one. So it's kind of a combination of these two slides. Like when these two, people, whether it's all within one person in some organizations, or if it's divided into two separate roles, and in other companies, like how do you see those two roles like working together? So are they like, how do they share? And I guess bringing it back to us, how do they do that in ML.net? But is also kind of my follow-up question.
Yeah, so for example, in data acquisition and exploration, a data scientist may use these tools. You can use Python to explore data. You can use R to explore data. I think Python is better. Pandas or is the obvious tool to explore data using Python. You can explore data using Power BI if you want to find some patterns between the data. So those are the tools that a data scientist may want to use in this step. But when you want to train a model and test a model, if a data scientist is training a model, of course they can use all these tools. A data scientist may also want to use Azure Machine Learning because you can use Python there. Then you can publish that model into an endpoint, so the development team can use and consume that endpoint to make inferences and predictions. But if a data engineer is building the model, training and building and trading and testing the model, you can use MLnet for both steps. And it's easier because then you can use that model, that file, that .zip file that it generates, so you can consume the model. Also these tools like SQL and databases, you can use that in data acquisition with a data engineer profile. Like I said, SQL is a great language for exploration data. In my first machine learning project, I used SQL because I didn't know Python back then, and it works. It was very, very fine. When you have to consume a model, it's hard to use R or our infrastructure or our architecture. Is easier if you use Azure Machine Learning to publish an endpoint, or ML.net, like I said. Actually, I'm working in a machine learning project right now. It was built in R by a data scientist, and they developed the whole project with R, even the consume of the model. Now this person is no longer in the company, and we are trying to reconstruct the project, and it's very hard to reconstruct that because nobody else knows about R. So the project didn't meet the standards of the development team. The code was not in a Git repository. We lost the code. We didn't have documentation. So we are having a lot of trouble trying to reconstruct that problem because they didn't use the right tool in the steps of the process. When you had to consume the model, you didn't have to build this step using R, especially if there was only one person in the whole team that knew how to code in R. So we are having a lot of troubles trying to reconstruct that project because that person is no longer in the company and the code was not in our repository. The data sets were not versioned. We don't know which it was the last version used to train the model. It was a chaos. So that's why it's important to know how to use the right tool in the right step of the process. And like I said, if you already have a .NET architecture in your development team, you can use the Git repository that you are using. You can use the application server you are already using, and it meets the standard you are already using. So it's easier if someone leaves the company, other developer can take the project.
So for between these two roles, I guess, do you and going back to your other chart, it seems like sorry, the one where if you can go back to the slide that that shows like the journey.
Okay.
Yeah.
One.
Does in a way, does it mean like the two different handoff spots here between data scientist and engineer? It's kind of like either in the supervised learning case, it can be data, whether that's in CSV or SQL or anywhere else, right? But it actually is labeled. So that's potentially one like handoff. Or the alternative, like on the other side of training and testing a model, that is the like model itself, right? So that could be a model that's either trained in TensorFlow or anything like that, or trained in ML.net.
Yeah, that's an interesting point, because in supervised learning, a data engineer can perform all the steps, right? They can explore the data, they can train, test, consume. But in another project, a data scientist cannot perform all the steps, because the step of the consume of the model, it's better if this is performed by a data engineer. That's a great point, because that's a great difference between the two profiles, the two roles.
So I want to kind of highlight some things that are coming in the chat, and thanks folks for posting. The chat is very active, so people are definitely engaged with your presentation, Diego. We'll switch over here real quick.
I hope my English didn't stink that much.
no, not at all. Folks are really, and it's not questions related to confusion. It's more people are sharing their thoughts and ideas. So we have Flying Rossolini here saying, today I finally put a name to what I've been doing for 25 plus years. Data engineer has a great ring to it. Great. So yeah, definitely add it to your LinkedIn profile.
I started that way. I didn't realize that, hey, I'm becoming a data engineer.
Right, exactly. There's something that I kind of want to go back to as well here. And we have, I lost it. Sorry, folks. There we go. So Flippy asked, you mentioned R scripts in the beginning, and you also just mentioned that, with this project that you're trying to rebuild. So Flippy asked, did you rewrite everything in C#, or is there a way to integrate the two? Our scientists love working in R, but most of our infrastructure is Azure.
Yeah, we didn't have to rewrite everything in C# because, like I said, we failed in selling the project. So we didn't have to do anything more. But if we could have sell the project, and if we would have to take it to the next level, to a larger scale, yeah, I definitely would have rewrite everything in C#, and I would have used ML.net. And if your infrastructure is in Azure, my recommendation is to use Azure ML if your data scientists don't want or don't like to use ML.net, but they might want to use Python, and Azure Machine Learning is great for that. Now, that also remembers me as something that in the last presentation of the ML.net conference, they said they had the same problem. They built this model in F#, and I don't remember the name of the speaker, but he said their team asked him to rewrite the code in another language because they didn't know F#. So It depends on the team you have and the knowledge you have.
Great.
I do want to add to this. I think that it is one of our goals with ML.net to sort of be the orchestrator. So we want to be compatible with a lot of other frameworks and technology stacks. So that's why if you look in our examples, we have like being able to consume Onyx models or being able to consume TensorFlow models. Part of that is making it so that, when dividing up these roles, there's the ability to have people working in the environment they want to work in on both sides of it, right? So that way, kind of going back to these roles, if you're a data scientist, you can go and do whatever you want in the languages you prefer. And then when you actually want to bring that to production and deliver it to customers, that hopefully we have a mechanism for you in ML.net to be able to consume whatever your data scientists have produced and bring it into your program. So with ML.net, you can wrap the model. You can do a little bit of data transformation if you need to make it so that the one example that's in my head is, if you're doing like image classification or object detection, if you have to load the pixels in a certain format, you can do that with ML.net pipelines, then pass that to the Onyx model or TensorFlow model and do your predictions. So we want to empower these teams that are used to different technology stacks and find a way to make it so that they can work well together and ultimately get the output of both team members into one pipeline in ML.net and find a way to integrate it into your applications. So for folks that are familiar with R and want some sort of interoperability there, I'm not too familiar with what like the output of like the models or what would be coming from R, but maybe we can find some interop story there to make it so your R and .NET teams can work well together.
And speaking of handoffs here, Theorem Geek has been making a few points here. So just highlight a few of them. So Theorem Geek mentions, I don't think a handoff is necessary. It's not necessarily a way to think about the data scientist versus data engineer role. When you think of data engineer, it's about building the data pipeline and platform. Data scientist is more about experimenting using models to answer questions. And then there's other roles apart from data scientists and data engineers, such as the ML engineer, software engineer, and data analyst. Any thoughts there, Diego?
The point that Jake made is great. A data engineer can perform some machine learning projects end to end, from the data to the consume of the model in production. That's why I like this role. That's why I became this like this. But a data scientist may have some specific role in a team, and you can also work with developers, with QA testers. All the team that you have in your IT area or in your company, in your team, it's great. They can help you. The key is to know the responsibilities and the scope of each role. Like I said, if you ask a data scientist to build a web service, a REST API, or microservices to integrate applications, you probably ended up having the same problem I'm having right now with this project I told you, trying to reconstruct a project that didn't meet the standards of the IT area, didn't meet the standards of the architecture, and they let that happen because they didn't know you can make a prediction, you can consume a model using another tools and with the standards you already have in your IT area.
Makes sense. So speaking of roles and responsibilities within a team, Philip has a question here. Where does business intelligence fit into all this?
I think business intelligence fits maybe before a machine learning project, because in business intelligence you can see some patterns and you can explore data, and maybe that's the beginning, maybe that's the genesis of a machine learning project, when you see the behavior of, I don't know, last year of data, sales data, or I don't know, any kind of data, right? If you look back in time using business intelligence, then you may want to approach a problem. Hey, how do we predict in time some behavior using data? So basically, I think business intelligence can be the genesis of a machine learning project. But I'm not an expert in business intelligence. Maybe anyone has another point.
Theorem Geek sort of provides their insight here. So BI, it's usually covered by the data analyst role, so usually building dashboard. And I guess Theorem Geek is asking for a little bit of clarification to that question, whether that's really the difference between BI and data analyst.
I don't think there's a big difference, right? You have to analyze data in BI. If you have a dashboard that doesn't tell you anything, that's not business analysis. That's just making reports. It's like Tyrion Lannister said. What unites people? You have to tell stories with data. I love that topic, because you cannot learn that in a tutorial or in a machine learning course. You have to know how to make the data speak, and that's something you have to learn by yourself.
I also highly recommend, as a engineer, engineering manager, PM, or anyone, I think that's really important. Like, when you're talking with data, have that story. Super valuable. That's the way to drive people to do things, like you said.
Also, another thing a data engineer can do is you can democratize data science. Sometimes in some companies, data science is like a small part of the business. A lot of people work with data. Small teams work with data. The other teams of the company, they don't work with data. But if you are a developer, if you are a data engineer, and you can build machine learning projects by your own, it helps you to democratize data science. So more people in your company, more people in your teams can work with data, and it's great. I love working with data.
That's really good that you sort of started steering that conversation towards democratization of machine learning, and also the learning aspects of it. So I'm going to lump a few of those, a few questions in here, because they're related to folks who are getting started, and understanding, like, what's the right path based on their skill sets to choose one of these roles, right, or perhaps any other role. We have a question here from Sharafuddin. And they mentioned, I prefer to choose data scientist. I completed a BSc, which I'm going to assume that means a bachelor's of mathematics with applied computer science. Is that the right choice? Would somebody who studied mathematics, would a data scientist role make good use of that skill set? Learn from that degree?
Yeah, it's a great choice. If that's what you like, is if you want to be the brain of your team, if you want to be Adrian Newell, that's a great choice. If that's what you like to do. I never studied mathematics a lot, so that's why I choose the path of data engineer. But if you want to be Adrian Newell, if you want to be the brain of your team, if you want to be admired by everyone, like, oh, you are the data science, that's a great choice. It's a great choice.
And
I was going to say, just to add to that, I think that someone in the chat also brought up a good point that, depending on the company you're in, they're going to require you to put a lot of hats on, right? It's not going to be as clear boundaries as these roles are defined, right? So they might hire you as a data scientist, but then expect you to be a data engineer or a machine learning engineer or something like that. And so I think that, you don't have to necessarily force yourself down one path. But I think that Diego brought up a bunch of really good points in this presentation, that if you're advertising yourself as one of those, just make sure you explore all the technology stacks for the different role, for the different hat that you're putting on, and make sure you're using the right one. And obviously we hope ML.net is a major piece of that for you. So I think you don't have to choose. You can kind of wear all the hats depending on what your company and customer needs.
Yeah, Ibrahim here sort of mentions that they're the third grade electrical engineering student who works as a full-time developer that wants to learn data science too. So that's definitely juggling a lot of things there. But you sort of mentioned, we talked a little bit about somebody who studied mathematics and wants to go down that data science role. But what about for somebody who perhaps, like you mentioned, Diego, you didn't really go deep into the mathematics, but you kind of still were able to find a role within machine learning and the data AI space. Pratik asks here, how would you go about migrating from a role as a .NET developer to a data scientist or engineer role with about a year of .NET developer experience?
My recommendation would be start learning about exploring data, because that's the difficult part when you are working with a very complex machine learning, and if you are a .NET developer, you may want to explore data and understand data before you develop a machine learning project. So that would be my recommendation. Start learning about data exploration. Don't start learning mathematicals and algorithms, because that's something as a developer you may don't have to build if you can use ML.net or AutoML. So my recommendation would be start learning data exploration.
And for somebody here, for example, like if you wanted to dip your toes into the space of machine learning, do you need to know what's going on behind the scenes with ML.net? Or is there a way, going back to that sort of democratizing machine learning, is there a way that ML.net sort of helps you get started without not really knowing too much of the details and later on maybe you can pick up on those details?
Yeah, sometimes you may want to know what's going on behind the scenes. Basically, you may want to know the how do you say, the explanation of the model. But I think ML.net has that feature as well. I haven't tried that feature, but I think ML.net has that feature about the explanation of the model. How the different columns of variables weights in the prediction or in the final decision. So sometimes you have to know that, because you have to explain why this is happening, especially if you are working with projects like sensitive projects. If you are working with I don't know, face recognition or so, or when you are working with people, something like that, you want to know what's going on, because sometimes you may want to fix your data to perform better prediction. It's how do you say, when you have to be more responsible with your data and with your machine and with your AI projects.
More ethical, more responsible.
More ethical. That's a word I want to use. When when you want to be more ethical with your project, you may want to have the explanation of your model.
Yeah, and that's a topic all of on itself. We could spend another hour talking about that.
Oh yeah,
which I think we should at some point. But I was gonna add. I actually forgot what the original question we were we were talking about was. But I think that when you're first getting started, I'd say I highly recommend you you do as Diego said, where like leverage AutoML, like try to not get too caught up in the details and too caught up in the algorithms of what's happening underneath, because I think you can. It's easy to spend the rest of your life digging into algorithms and then not actually sort of putting it into use. So what AutoML allows you to do is, just pass in your data, get a model, start being able to do predictions, see how you can integrate that into your application, so you can see like the end to end and kind of get it working and see if it's a viable path, right? Because essentially, somebody else commented in here about you want to make sure you're using the right model. So that it's really hard to, basically you have to create AutoML if you want to choose the right model, right? Like you have to iterate over a lot of different algorithms, change a lot of the hyperparameters, and you end up doing that anyways. So you might as well use a tool that's already been built to do that, like our AutoML. And then from there, it's still valuable. And that's why we like when you're done with ML.net, our CLI or model builder, we give you the training pipeline so you can see what's actually happening under the cover. So there you'll actually see what algorithm we're using. And then you can go research it and you can go learn the math behind it and you can go figure it out. But by taking that approach, I think it helps you sort of get rid of all these hundreds of models that may or may not work, and then allow you to dig into the one that AutoML found to work and learn more about it and help build that story of what's happening and making sure that you're doing it ethically. I think that, I don't know, it's sort of like you dig deeper. It's an onion, right? And I think AutoML helps you stay high level first, and then you can keep peeling back the layers to learn more about how the process is done.
Yeah, you certainly find that, personally, writing documentation, right, for folks, that's certainly the approach or the thinking behind it. It's I want to achieve something, right, and I'm going to find what the easiest path or the path of least resistance is to achieving that, and show folks, hey, here's sort of that end to end, like you were mentioning, Jake, of how you go from point A to point B to achieve that particular task, and sort of, to a certain extent, hand wave a little bit over the details, right? But later on, once you've got to kind of get a sense for like the basics or the process, kind of like what Diego showed in his sort of diagram there, where it's like here the data science typically is involved with sort of the data exploration and training the model, and then there's sort of a handoff to, say, a data engineer for testing and deploying of the model, right? So once you get the idea of, okay, well, these are the steps that I need to perform, then you can start digging into sort of those details as you need to, right? To refine and make sure that that you improve upon the practices and your model. Yeah, Theorem Geek here mentions do something like data Kaizen, continuous improvement, start with a model, then iterate with better models.
That's DevOps plus ML, MLOps. Yeah.
Another topic we could spend another hour on.
Another big topic.
Yeah. So So as you can see, folks, right here, we've sort of mentioned them, but each of these topics could easily deserve an episode, and we still wouldn't get to the bottom of all of it in one episode. So yeah, but there's, again, just thanks to folks. It's been really active chat. People seem really engaged, Diego, here, but it does seem like we are getting close to time. Do you have any sort of last words? And if folks want to reach you, where can they do that?
My last words would be, I'm sorry for my English. I'm sorry I have to put that to
No. This has been great. Like I said, folks, I think have found this very interesting, and they've been engaging very actively. So there's no need. You did a great job here.
Right, great. I can help. It's been great being here.
You did great. We've also done multi-language. We've already been multi-language on these community stand-ups before. So if you want to come back in any other language, we're happy to have you on as well.
Algún día lo haremos en español.
Para el próximo episodio.
Your English is better than my German.
All right, folks. Well, we thank you for tuning in for another episode here of the Machine Learning Community Stand-Up. Make sure if you want to check out the other episodes, the last one I think we had .NET Interactive. So make sure to check those out. And again, just want to really thank Diego for coming on and joining us and teaching us a lot about sort of different careers and roles within data science. So thanks a lot, folks. Thanks for joining, and we'll see you later. Take care. Bye.
See you later. Bye.
See you.